The simple analogy of a maze with only three binary decision gates graphically illustrates just how easy it is for a supply chain to fall over. It's not hard to imagine that as a supply chain lengthens and becomes more complex, with more interfaces and decision points, the odds of the system delivering the right products in the right quantities to the right standards, on time and in full, become longer and longer. Moving to a more realistic model, let's consider a typical supply chain for a large retailer with several branches in different locations. The information flow is shown at the top of the diagram, generally going from right to left, and the physical movement of goods is along the edges and across the bottom, flowing from left to right. As the products fly off the shelves, information is collated, aggregated, washed, dried and ironed in MRP or ERP systems, and then exchanged across the supply chain in the form of orders and forecasts. Supply errors are most likely to occur in the interfaces between companies, transport systems and information exchanges, represented on the map by yellow starbursts. If every part of the supply chain consistently delivered a 95% service level, we'd expect the retailer and consumers to be fairly satisfied. But in reality, when bolted together, the entire system is only delivering a service level of 46%. All those yellow starbursts are having a considerable multiplier effect on the errors found in every part of the supply chain. So whilst everyone is working their socks off delivering what they believe to be great products and services, the customer is frustrated and disappointed more often than not. This is a very common phenomenon in many supply chains. So what can be done in practice to minimize or eliminate these errors? The usual response is to implement ever more complex control systems to micromanage every element of the supply chain. But this in itself adds complexity. A far better strategy is to simplify the supply chain where possible. Many executives are initially skeptical at such an approach, but here are some logical first steps that deliver valuable initial improvements on the journey towards an optimized supply chain. The key is to ensure every member of the supply chain has timely access to customer consumption. That means the raw data, with no massaging or manipulation. The primary reason for this is to ensure everyone works in harmony with the customer dictating the pace. The moment this is implemented, everyone can see where there's too much or too little stock, or production capacity, or freight capacity. At this point, level loading of orders and forecasts is a logical step, bringing substantial benefits to factories, warehouses and procurement systems across the supply chain. And if facilities are in relatively close proximity, it's easy to switch to a replenishment model based on actual consumption, backed up with a correctly sized buffer stock in key locations. Kanban signals drive the stock movements and provide a useful check of the real consumption data. A disciplined team can operate a correctly designed replenishment system with far greater reliability than the best matched MRP or ERP system because it's market-driven, self-checking and simplified. Over time, this model delivers higher customer service at lower overall cost than any other system. It's a system with fewer interfaces, so there's less opportunity for error. And because subjectivity is eliminated from some of the remaining interfaces, the probability of potential errors is reduced, represented here by the grey starbursts. To illustrate the potential effect on the service levels of our supply chain model, consider the results of a computer simulation summarized in the X-bar chart. The data is presented chronologically as if each scenario ran for 2 years. It shows that substantial improvement is possible by simplifying the supply chain processes and making marginal gains in individual elements. The data in this simulation is fictitious, but the improvement opportunity very closely resembles that of many existent supply chains. Improvements in system complexity, lead times, transport, space utilization, inventory, labor, administration and packaging can deliver substantial benefits to most of them. You could start by drawing your own value stream map and identifying the primary causes of service level failure. From there, you're only a few hours away from the first improvement.